Good evening, everyone. My name is Tanayati. My register number is URK24AI 1077. So today I'll be explaining about object-oriented programming lab experiment number 8, that is multi-threading using Java. So our aim is to implement a Java program that demonstrates the concepts of multi-threading, where multiple thread execute concurrently to perform tasks such as sorting, computation, or displaying messages simultaneously, improving the efficiency and performance of the program. Okay, so multi-threading in Java is a process that allows two or more threads to execute concurrently, helping a program perform multiple tasks at the same time. A thread is the smallest unit of execution within a process. In Java, threads can be created in two ways: by extending the thread class or by implementing the runnable interface. When a class extends the thread class, it overrides the run off method to define the code that should execute in the new thread. And the thread is started using the start of method. Alternatively, a class can implement the runnable interface and override the run of method. This object is then passed to a thread instance, which starts execution using start of function. The start of method internally calls the run of method and initiate concurrent execution, whereas directly calling run method will execute the method sequentially like a normal function. Java provides rich support for managing multiple threads, such as setting priorities, pausing, and synchronizing thread execution. Overall, multi-threading improves performance by allowing tasks to run simultaneously, making programs more efficient and responsive. Now let's go to the coding part. The program part. Write a program which takes as input a huge array of numbers. This array is split into subarrays, and n thread applies a bubble sort on each of the n subarray. Lastly, another thread merges the n sort subarrays into one with the same size as the original array. The course resulting array should be sorted. Let's go to the coding part, implementation part. Yeah. Yes. So we have imported the java.array module. Then yeah, we've declared a class that is parallel bubble sort. We've given the main function, use the scanner class, and yeah, then we have asked to print the size of the array. Then the size of the array has been stored in array size variable. So next is we declare an array, that is huge array equal to new int of array of size. Then size we have already asked the user. And yeah, next is we print the enter size array integer separated by space or new lines. Then we use for loops to uh, access the elements in the array. Then we store it in another array called huge array. Then next is like we print the original array. Next is like then we give the number of threads to use. It's stored in num threads, the variable called num threads. So we've used a variable called start time. The data type is long, and we give a system.current time millis. Int of array sorted array is equal to parallel sort huge array num threads. Long end time is equal to system.current time millis. Then a variable called duration, data type is long, and time minus start time. So we have printed the sorted array is array sorted in sorted tool using this array.toString sorted given the sorted array, and is so using is sorted of sorted array duration plus m. So then we then close the scanner. Then we declare another called static boolean is sorted into array. Then we access the elements in for loop, and if array of 1 is greater than array 1 plus 1, then we return false, else we return true. So another called a public static int parallel stored, that is int of huge array and int n threads. Int array size is equal to huge array dot length. So okay, next is fallback to single threaded if too small or thread is equal to 1. Then if array size less than 2 and or n thread is less than or equal to 1, then we bubble sort huge array. Then we return the huge array. If n threads greater than array size, then like n threads equal to array size, then what array sub array size we declare a variable, and that is array size by n threads. And yeah, we've declared a multi-dimensional array, that is sub array, uh, that is new of n threads array. Then int current pose is equal to 0, and we have used a for loop again in order to access the n threads values. And in length we give the I equal to n thread minus 1. If it is true, then array size minus current pose or sub arrays. So yeah, then the next line is system.array copy of huge array, current pose, subarrays, 0 and length. So current pose is equal to current pose plus length. So next is executor service, executor equal to executors dot new fixed thread pool and threads. We've used again for loop in order to access the end thread values. And if final index equal to I, executor dot submit bubbles, and then we bubble sort the arrays, elements in the arrays. Then we use this try catch block to maintain this to in order to get a smooth running. We use this try catch block, and yeah, we've given again in the loop to do the necessary program that needs to be done. And yeah, we've given the conditions, and let's run the code. Yeah, yeah, we've run the code. I'm going to write the size of the array as 3. Uh, Okay, so I'm giving 2, 3, 4. Yeah, number of threads to use, I'll just say 3. Yeah, this is the output for the code. Um, so yeah, now the program has been executed and the output has been obtained successfully. Thank you.